This learning module corresponds to section 1.1 in the book, Understanding Our Universe. It is entitled, Astronomy Gives Us a Universal Context. The learning goals of this learning module are to relate our place in the universe to the rest of the universe and to be able to describe our astronomical origins and explain how patterns of our daily lives are connected to the universe. There are 4 parts to this learning module: our place in the universe, the scale of the universe, the origin and evolution of the universe, and an astronomer's toolbox. They correspond to the subsections in Chapter 1, Section 1.1 of the textbook. So we begin with our place in the universe. Our cosmic address is a kind of nested hierarchy or inclusion hierarchy, meaning that each entity is a subset or a member of a larger or next level of the hierarchy. Our place in the universe is given by our cosmic address: Earth, Solar System, Milky Way Galaxy, Local Group, Virgo Supercluster. We live on Earth, a planet orbiting the Sun in our solar system, which is a star in the Milky Way Galaxy, and the Milky Way Galaxy is a large galaxy within the local group of galaxies, which in turn is located in the Virgo Supercluster. Earth is a relatively small planet. Earth orbits an ordinary star. The Sun orbits a supermassive black hole at the center of the Milky Way Galaxy. The Milky Way Galaxy is a spiral galaxy containing 100 billion stars. The Milky Way is just one galaxy of our local group of galaxies. The local group is a part of the Virgo Supercluster of galaxy groups. The Milky Way is just one of billions of galaxies in a universe that is 13.8 billion years old. Our cosmic address is Earth, Solar System, Milky Way Galaxy, Local Group, Virgo Supercluster, Universe. The Voyager spacecrafts, which were launched in 1977, are very much like postcards. There are 2 of them. The Voyager spacecrafts have a return address. That gold disc on the right is a map showing Earth and the solar system, and they also have a greeting. Like the message area of a postcard, they have this golden record with greetings, music, and natural sounds of planet Earth. These missions, launched in 1977, continue to send back data to the Earth even to this day. They are the farthest from Earth of any man-made machines. There were 3-part missions. One was to conduct close-up studies of Jupiter and Saturn, Saturn's rings, Uranus and Neptune, and the larger moons of all these planets, to explore the Kuiper Belt, and to travel into interstellar space, eventually becoming a fossil of our culture. Voyager discovered that Jupiter's red spot is an anticyclonic storm bigger than 2 Earth diameters across. Jupiter's moons show incredibly diverse satellite geology, including active volcanoes on Io with plumes extending up to 300 kilometers above its surface and ejecting material traveling at velocities of up to 1 kilometer per second. Many think that Voyager's discovery of active volcanoes on Jupiter's moon Io was its greatest discovery. Small moons and a ring were also seen for the first time. Using data from Voyager, researchers concluded that the magnetospheric rotation strips away material from Io to form a torus along Io's orbit around Jupiter. Jupiter was also seen to have cloud-top lightning bolts and polar auroras in its turbulent atmosphere. The Voyager data at Uranus showed its planet's rate of rotation is about 17 hours and 14 minutes. The spacecraft also found a Uranian magnetic field that is both large and unusual. Uranus's magnetic field is tilted 60 degrees and offset from the center of the planet by about 1/3 of its radius. Voyagers also discovered that the sunlit pole radiates large amounts of ultraviolet light, and the cloud-top temperatures of about -350 degrees Fahrenheit exist over most of the planet. 10 new moons were found. Uranus has a broad ring system, and it is distinctly different from those at Jupiter and Saturn. On the left, we see Uranus's atmosphere over a 4.6-hour interval on January 14, 1986, and on the right, we see images of Uranus's moon Miranda showing complex terrain. In 1989, Voyager 2 passed about 5,000 kilometers above Neptune's North Pole, and about 5 hours later it passed 40,000 kilometers from Neptune's largest moon, Triton, the last solid body the spacecraft will have an opportunity to study. To summarize, the Voyagers found 6 new moons. They showed that Neptune's rings are complete but are diffuse, and the material is so fine that it couldn't be fully resolved from Earth. A total of 4 rings is seen. There are several large dark spots similar to Jupiter's. The magnetic field is highly tilted, 47 degrees from the rotation axis, and offset from the center by about half a radius. There are active geyser eruptions seen on the moon Triton, and Triton's retrograde orbit suggested that it is a captured object. To date, the Voyagers give us about our best data from Uranus and Neptune. However, when we study Jupiter and Saturn in greater detail, we'll be using data from Cassini for Saturn and from Galileo for Jupiter. In February 14, 1990, Voyager 1 took a panoramic photo of the solar system it was leaving. This mosaic shows the planet portraits, and the Earth is just a tiny point from a distance. That's us in that circle, annotation on the image. That tiny point is Earth. In August 2012, Voyager began its final mission of exploring interstellar space. Having given much needed information about the heliosheath and the heliopause at the outer extent of the Sun's influence. It is anticipated that between 2020 and 2030, Voyager will no longer be able to power its instruments. At that point, the Voyagers will be our ambassadors to alien life. They are much like that cosmic postcard. Scientists predict that the Voyagers will orbit the Milky Way galaxy long after the Sun becomes a white dwarf and the Earth is destroyed. The Milky Way is just one of hundreds of billions of galaxies in the known universe. In summary, our cosmic address is a nested hierarchy. We live on Earth, which is part of the solar system, which exists in the Milky Way galaxy, which is part of the local group of galaxies, which is part of the Virgo Supercluster in the known universe, and we don't occupy a special place in the universe.